So we are moving right along to 13.3, graphing trig functions. Now that we've done amplitude, we're going to add another transformation, and we're going to be looking at vertical shifts. All right, so vertical shifts is moving up or down. So what we know so far is that right here, A, that's our amplitude. And that is multiplying to make it skinnier or wider, stretching or compressing. Now what we're going to look at today is adding or subtracting outside of the function, and that's going to move it up or down. Up is going to be plus, down is going to be minus. So we can kind of see an example here. Black function is our standard sine of x. And if we put a -2 on the outside, it takes all of our points, so like our starting point here, and it shifts it down 2. Takes every point and subtracts 2 and goes down. If we had +2, it would move up. All right, so we're going to get into some examples here of moving these sine or cosine graphs up and down. All right, example number 1, we have y equals cosine x plus 1. So if we know that cosine always starts above the midline, it starts at 1, from there we could just move our point down, move the next point down, move the next point down. If we need to make our table, we can go ahead and make our table as well. So as we get better, we can kind of go without using the table, but we'll stick with it for now. So if we make our table of cosine of x, so we have cosine of x. On our x-axis, we have 0, 90, 180, 270, and 360. Cosine always starts above the midline at 1, and then we go 0, -1, 0, finishing back at 1. So what we're going to do is take all these values and add 1. So if we have 1, let's label our graph first. So say we have 1 here, 2 here, -1 here, 2 here, -2 here. Then we've got 90, 180, 270, and 360. I just like to spread my y-axis out because I find it easier to sketch through. As long as we have it labeled accurately, we're good to go. So cosine usually starts at 1. However, now I'm adding 1. So 1 plus 1 is 2. 90 is usually at 0. If I add 1, I'm up at 1. 180 is usually at -1. Add 1, I'm at 0. 270 is usually at 0. Add 1, up at 1. And last, 360 is usually at 1. Add 1, we're at 2. Got the same general shape, so we're just going to go ahead and sketch our cosine graph. So we took our graph and we just shifted it up 1. Notice when we add or subtract, move up or down, we're shifting our midline. So our midline went from here and it shifted up with it. Now the middle of the graph is at where our vertical shift is. It's at 1. And we're still starting up above that new midline. Example 2 is y equals sine of x minus 2. So I'd like you to go ahead and try this one on your own. Graph it whether with the table or just knowing where the points are and shifting them. But I'd like you to go ahead and try this one on your own, pause the video, and then play the video to check your work. All right, hopefully we have this graph here. So our first point's at 0, -2. Our next point's at 90, -1, 180, -2, 270, -3, and 360, -2. And our midline shifted down to that -2. That's going to become important in the next example. So these points are super helpful if we just know where it is. If we find that first point, we should hopefully just be able to bounce up and down and start getting the hang of graphing this a little bit quicker.
All right, example number 3, we are graphing y equals 2 sine of x plus 1. So we've got two transformations going on here. First, we've got 2, so we are multiplying by 2. That's our amplitude. And then we have plus 1, so we're going to go up 1 from our original parent function. So if we're graphing sine, we go ahead and make our table. Sine is 0, 90, 180, 270, 360. And sine starts at 0, so we go 0, 1, 0, negative 1, 0. Now, multiple transformations, you can obviously do it on your graph. Just kind of, this is where I start, multiply by 2, move up 1. So we always want to do multiplication before addition, just like order of operations. We could also make our points here on our table. We could multiply by 2, then add 1, and graph those final points. So if you want to use the table, go ahead and use the table. So first I'm going to start by labeling my graph. So I have 0, 90, 180, 270, and 360. And then I'm going to go 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. So if I were to go through and do this process, I take each of my points and I'm going to multiply by 2. So I have an amplitude of 2. So 0,
we know that
times
0,
2,
180, and 360 are always going to
0
be on our midline.
1 times
we shifted
2,
them up 1.
2,
So
0,
if we draw those points,
2, 0. Well, now
0,
I not only want to have an amplitude of 2, but I want to take this whole graph,
always
and
know
now
for sine,
my graph with an
they're going to be
amplitude
on
of
our
2,
midline.
move it all up
What's going
1.
to change?
So if I take
with
all
the
these points and I add
amplitude
1, I'm now going to be
is
at
90 and
1,
270. Those
3,
are going to get
1. Negative 2
taller
plus 1 is negative 1.
at those
And
2
then
points.
up
So
at
90,
1. So you can see that all my zeros
if we have
are
an
going to be on my
amplitude of
midline.
2,
And remember, my
has to
midline
be
just
2
shifted
above our
up
midline.
1.
So 1, 2.
So if I go
And
ahead
then
and do this, I can
270 's
graph just
below,
from these
so
points.
it's
I'm going to be
2
at 1.
below our
So I took
midline.
my original point, went up 1.
So now we've taken everything
next point
up
went up
1, but
to
we've
3,
also used our amplitude
back down to 1.
multiply by 2. So if I draw this in, we'll start by drawing
Going to
this
be
in.
at
I've got my sine graph.
negative 1.
So what you always want to do is
And then we're going to be
shift your
at
midline up 1
again.
and then
So if I go ahead and
plot the
draw my
points
sine
on your
curve,
midline and then use the
going
amplitude for the
through my
points that are
points,
off of
this
our
would be
midline,
my
because
new
that's
graph.
what we're going to end up
So
multiplying.
if I draw in
Those
my
points that are
midline,
0 should stay on the midline
let's
always.
draw it in here.
And you've got 1 in your homework to practice like this, and then when we come into
I draw
class
in my new midline
tomorrow,
my midline
this is when we're going to
moves
continue
up. Originally it's on the
practice
axis,
more
but
of
now we
these
shifted it
multiple
all up 1, so my
transformations.
midline's at 1. I can check my graph. Everything moved up 1 with my midline, and I have an amplitude of 2. It's 2 away from the midline in both directions. So I have an amplitude of 2, and I shifted up 1, so this would be my new graph.
All right, so example number 4, we want to identify the transformations and write a sine equation, not a cosine equation. We just want to write a sine equation, so let's get rid of that. So in order to do this, we need to identify where the midline is to figure out if we start on or off the midline, so sine or cosine, and then how much we've shifted up or down. So if I establish where my midline is, it's what splits this in half, so it's the same above, same below. So here's my midline. Now I am 1 above, 1 below, so I don't have any amplitude. I didn't multiply. But I start on my midline. So since I start on my midline, that means I have a sine graph. And then I want to figure out, well, how much did I move up or down? Well, here's where we normally start. from this point, we went down 2. So if we go ahead and write this equation, we have y equals, we don't have any amplitude, so we don't have to multiply. We just have sine of x minus 2. And we need these parentheses here because that minus 2 needs to be on the outside of x, since we'll get to what happens when it's on the inside. So minus 2 is on the outside, meaning it moves down. Here we got example number 5. It says identify the transformations and write a cosine equation and a cosine equation. So just a cosine equation. All right, so first thing, identify our midline, where this graph is cut in half. So if I do that, my midline is going to be right here because I have 1 below, 1 above. So if I have 1 below, 1 above, I have no amplitude. But here's my midline, and I start above my midline. So since I start above, I know I have cosine. And usually, cosine starts at 1. So cosine normally starts right here. So how much did I shift up? I went up 2. So my equation would be y equals no amplitude, so not multiplying by anything, just cosine of x plus 2. So it's not always how much did it shift from 0, it's how much did it shift from its starting point. And it shifted up 2 from its starting point. So if I look at this point here on the midline, it started at 0 and went up 2 as well. I can check every single point. All right, we got a tricky one here. So example number 6, once again, we're just identifying the one in bold, just cosine. So if you want to go ahead and identify the transformations and write a sine equation, pause the video, do that, and then play the video for the correct answer. We got to bring it all together here. So draw your midline, what cuts your graph in half. So we draw our midline right here. We start on our midline, so it is a sine graph that we're looking at here. And if we look at for an amplitude, we're not just 1 above, we're 3 above. So since we went 3 above our midline, our amplitude is 3. We're multiplying by 3. And then since we went from our starting point for sine from 0 up 1, we have that plus 1. So our equation is y equals 3 times sine of x plus 1. Now go ahead and try your 13.3 worksheet on vertical shifts, getting some more practice with this new skill.